Okay guys, I just want to help you out with the graphing a little bit. I know I kept saying I make this video, so here it is. This is what you should open up. So when you click on mine, it looks just like this, or maybe you have yours. And you're going to start off by duplicating this sheet. And the reason why we want to do that is because we want to have like our two groups, not really quite a control and experimental. This is just a simulation. So we want to see what happens when there is a large population, and we want to see what happens when there's a small population. You can leave your frequencies at the 4 and the 6, or the 40 and 60%. I'm just going to change it to something a little bit more extreme. Just make sure you change it on both of the sheets. And if you do it before you do the duplicate, you don't have to worry about it. Now this second sheet though, we're going to rename it to represent our small population. Okay, so small population, and we'll make it around 12. The smaller the better. So now I'm large population sheet, small population sheet. If you just kind of drag this down by holding the button down, there's a little count at the bottom right that tells you what you're at. I'll show you in a second. Right here, count 12. So that's 12 individuals. So gametes, zygotes, and all of that. I'm going to come to 17, just click on 17, and then I can scroll all the way down to the bottom, hit the shift button, click on this, it's going to select the entire thing. Then I just hit delete, all gone. So now when I scroll back up again, my entire population only consists of 12 individuals. So I have my large population, my small population, and we're testing the effect of population size on maintaining this Hardy-Weinberg equilibrium. We know that's one of the conditions that needs to be held, and we can kind of see what happens across these generations using this formula, okay? And we're seeing how it does change a little bit. If I'm gonna hit like delete or enter or something, we're going to see those changes, okay? Here our large population, a little bit more consistent. We need to graph this, and you can sit there and you can kind of like write out all the things if you want, but I'm going to show you a much easier way. So by doing this, AA, AB, BB, okay? So those are the individuals in each population. I just type in equals, and then I go to this sheet, and I just click right here, 38 equals, I go to the sheet for the AB individual, enter. Now you're going to notice the numbers are changing because remember, we have that random. So every single time you do something, the whole kind of formula sheet changes, but we have those values. So that's our first generation, now our second generation. Equals, you just scroll over, make sure you go, I have them easily labeled generation 2, right here, enter. Go right here, equals, back here, enter. Yeah, this is going to take a second, but it's totally worth it because it's going to do a nice graph for you. I'm just going to make up the numbers in the last one, or whatever, I'll do one more. The time I would take to explain it would be about the same. So we could rename this, by the way, data. It's our data sheet. We could drag it to the end if we wanted to. Okay, equals large population, this value equals, and then right here is our last one. Okay, great. So now we're going to select this data. We're going to go to Insert, Chart, and this isn't exactly what I want right now. Doesn't look good. I've got my AA is my x-axis, 43, 37. I don't know what's going on here. If I go over here to switch rows and columns, this is really what I want. It's not giving my full data set though. It only has AB and BB, so that's kind of a problem here. X-axis, I don't want to be that AA. That's the problem. And there we go. So I didn't want to use that row as the headers. Now I have the AA, AB, and BB value. And what's good is I can kind of see the change. So if I do something on one of these sheets, we're seeing the slight change, the variation in real time. You're going to do this for all 5 generations. So just be aware of that. And then what you can do is once you have it all in there, you can just do a screenshot So on a Mac, it's Command Shift 4. Command Shift 4 brings up these little crosshairs, and I could just go like this and select my data table and my graph for it, which makes your life really easy. That's just the large population. You're going to do the same thing for the small population. So you would do the same thing, equals, come here, go here, hit enter. Same thing, equals, go here, hit enter, here, equals, hit enter. Now, I'm not really one for like manipulating the data, but I would really like you to do a screen grab on one of the ones where the large population looks fairly consistent and when the small population has experienced drift. So there's totally a chance that drift isn't going to occur and your small population is going to look just like your large population. Well, that's not really what we're looking for, right? And you're going to see more often than not, it isn't going to be similar, but there's always the chance that it would be. So maybe, hit enter a couple times, try to get it so that you really see some wacky numbers in your small population and you see some more consistency in your large population just to reinforce this lab. That's the graphing part. Any other questions, just feel free to email.